My name is Friederike Marschalk. Uh, I'm the head of marketing and sales at codixx. And today we're going to look at polarizers in quantum optics. What are polarizers doing in quantum optics? What are some technical challenges? And then I've selected 4 example applications where we can take a more detailed look at. First, a few rules for the webinar. Please turn your camera off and your microphone. There will be a Q&A at the end, and then we can discuss any questions that you might have at the end. Okay, so why does polarization matter? So in quantum optics, polarization isn't just a property, it's a data carrier. So the polarization is the qubit, the quantum bit. So if your polarization purity is off, your quantum state is corrupted. So this affects everything from experimental visibility to the security of, for example, an encrypted link. So it's used for preparation, manipulation, and analysis of single photons. And like I said, these stakes are, so you need a high purity to get low error rates and a better security. And what are the technical challenges in specific for quantum optics? It is a little bit similar to a lot of other applications, but in general, quantum experiments or quantum applications are usually photon starved. So it's not an option to lose any signal to poor transmission or to have a low contrast ratio, extinction ratio, because you want to really be able to distinguish between quantum states without any noise. So really the high contrast ratios, extinction ratios are necessary here. You need the high transmission. There are different wavelength ranges which are used for quantum optics, so a little bit of flexibility here. And then you have the robustness, which is necessary because there are a few applications which are, for example, for satellite application for communications. They have the whole launch settings, etc., to take care of. And then, of course, you don't want your application to just work for a few weeks or so. Ideally, you have the same low wavefront distortion and polarization axis accuracy, etc. We have this for years to come. So you always get the same data. Looking into applications, I think at least the one I got first in touch with was the quantum key distribution, which is basically the gold standard for security. So here, the information is encoded in photon polarization. You can see it a little bit here in the graph. This is I think, most often used system for quantum key distribution, the Alice and Bob module, where you have Alice sending the information in different polarization axes, basically. And then Bob has to decode everything to get to the right information. And here you have the orthogonal or diagonal directions. And this is actually something where our pattern polarizers have been used in quite a few experimental setups because our pattern polarizers can do all these different polarization axes here in the same polarizer. So the challenges here are it's usually over long distances and there are lots of loss in photons, so every photon counts. And the goal is to get a long-term stability in terrestrial and in fiber networks. And because due to the long distance, the polarizers must be exceptionally stable over time to prevent any key drift. So here you can see the pattern polarizers, which we've made. So with 4 different polarization axes within one polarizer. Another application would be quantum computing and quantum gates. So in photonic computing, we use light to perform logic. So our polarizers act then as the routing components in these gates. A high waveform quality is essential, and any distortion ruins the interference required for quantum logic. So there are lots of different photonic logic gates, like the control NOT, for example, which relies on the indistinguishability of photons. This requires a perfect overlap in the temporal, spectral, and polarization domains. Yeah, it's quite so. If you want to dive much deeper into these different logic gates, there are tons of different ones. Everybody has their own complexity and their own basically what they are doing. So it's quite a deep topic there. Then we have linear interferometry, which is also used in quantum computing. For example, for the Hong-Mendel effect. What they all have in common is the requirement for the precision axis alignment and the good wavefront distortion or low wavefront distortion quality. Another application would be a quantum eraser. The goal here is to control or restore interference through polarization. So in this picture here, you can see a setup which is based on the double slit experiment, which probably everyone has done in physics, so once upon a time. And here in this double slit experiment, it's further enhanced by the polarization manipulation. But you can see here, the top picture has basically like the usual double slit interference, what we've probably all seen in our physics class. And the difference here is you have this polarizer in front of your light source, and it has a horizontal and a vertical polarization axis. So, and each slit will have a different polarization axis, and this means that the interference will be lost. So this would be what it looks like after the path labeling, and then you can add another polarizer to in a different angle, for example, like 45 degrees. And this one will eliminate all these differences, which so the difference between the horizontal and the vertical axis, which we had before. And then this is what it looks like afterwards. A little bit like the first picture for the double slit, but much more sharp. For this setup, the requirements are the high axis accuracy, high contrast and extinction ratio, because you want to have a pure signal, and also the high spectral stability. Another application which has been getting a little bit more popular in recent years, at least it's what I saw from my customer side, is the ground to space satellite communication. It's a little bit like the quantum key distribution system, where we had the Alice and Bob module, but now we also have Charles. So Charles as a satellite, which interacts basically between those two for the secure communication. So the goal is to build a global quantum network for the secure communication. And so this application is the ultimate stress test for our polarizers. They must survive rocket launches and the harsh radiation and vacuum of space without any degrading. But yeah, so for satellite payloads, it's usually 10 to 30 years. And over the whole time, the polarizer doesn't have, shouldn't have any influences due to degrading or thermal cycling, etc. So for a standard plastic foil polarizer that would outgas or yellow, that's not an option. So they're definitely our polarizers would be the go-to. So, but why are our polarizers so special? Well, how do we enable all these amazing applications? Well, we use silver nanoparticles in glass. So this means the silver particles are completely embedded inside the glass. Whatever doesn't hurt the glass won't hurt the polarizer. They're resistant to heat, chemicals, radiation, while providing world-class contrast ratios. So we have a pretty unique process to do that. So we have all these prolate silver nanoparticles inside the glass. We have a really high degree of accuracy of the polarization axis because we can manipulate all these single particles. The main advantage is it's an absorptive, not a reflective polarizer. Can endure temperatures up to 400 degrees. Is chemical resistant, like I said, whatever doesn't hurt the glass won't hurt the polarizer. And we can do it customized for specific wavelength ranges. So in conclusion, so whether you're performing a quantum eraser experiment in a lab or launching a quantum key distribution satellite, the polarizer is the heart of your system, and we offer the precision and robustness needed for the next quantum revolution. We are a reliable partner for research and aerospace. So I think by now, most of the big space agencies have already used our polarizers and are quite happy with them. So we are, good partners there. And a final note, codixx AG is, we were founded in 1998. We are based in Germany. We make the polarizers for UV, visible, and infrared range. And our main part is to get the polarizer customized just as you need it. If you would like any more information, feel free to visit our website. Otherwise, thank you for your attention today. And if you have any questions, please feel free to ask them now. You could either turn on your microphone or write in the chat as you would like to do it. So while everybody's thinking, oh yeah, there's a question.
Yeah, it's for the tiled polarizer where you had 4 polarizers on one surface.
Yes.
How small is the gap between the polarizers?
You mean the gap between each different polarization axis?
Yeah, there are 4 areas, and I guess they're put together from 4 separate pieces, so there must be some kind of gap. How large is that gap?
Usually the gap is defined as being smaller than 100 microns. But we also have made versions where a gap was absolutely not acceptable. So we did overlap the polarizers. So it's basically like cross band in the middle to rule out any interference.
Okay, and how small can each tile be?
That depends. How small do you need it? So right now, I think the smallest one we've done is with each tile being about 60 microns by 60 microns. So we are not yet at pixel size for a sensor, but we are working on it. And we are looking forward to, if there's anybody working in that range, it would be perfect to work together. All right, any more questions? Okay, otherwise, then, oh, yeah, there's another question.
Yes, Frederick Ruud van der Noord here from the Netherlands, Talentelo.
Yes,
Yeah.
hi.
Good morning. Thank you for your presentation. Always learning moments. Can we find your webinar later on your website? Because I know two more colleagues are interested, but were not available today for joining us. But I like to share it with them, and so if you have it on your website, it will help us.
Yes, our student in marketing is already busy, and he will put it on the website. I think it would take about 2 or 3 hours to get the recording on there, and then it'll be on our website for the next month.
Okay, good.
So yeah, feel free to watch anytime later as well. Yeah,
Thank you.
yeah, thank you.
Okay, bye.
But yeah, otherwise, you can still think of any questions. Next month I'll talk about a polarizer selection, because there are many different polarizer types on the market. How to select the right polarizer for your application, and then as a little bit of an outlook for this year, I have selected a few, a little bit on applications, a little bit on designing, everything around polarization. You're free to welcome to join us. You will also find these dates on our website. Otherwise, if you have any questions, later on, feel free to get in touch, reach out to us. We are happy to help you. All right, then thank you, everyone. Have a good day.
Frederick, it was nice talk.
Thank you. Yeah. Bye bye.
Bye.